Okay, well, here we go. We have our third example on how to find the standard form of an equation of an ellipse. Now, in our previous examples, we had major and minor axes, and we went through various different examples of how to do this. And as you can see, I still have the information above that will help us find these different equations. And the equation we're looking for are one of these, which are both one of the standard equations. Now, once again, just kind of reiterating what we're looking for, we want to look for the center first, okay, because that will help us identify the major axis, because that will help us find where the A and B go, and then we can fill in the A and B as they come to us. So, without further ado, given in this equation, we are given this information. The information says we have a center. Awesome. All right. We have a center which is located at 3, 2. So we can start out creating our equation right away. We have x minus 3. That's going to be squared. That's going to be plus y minus 2. That's going to be squared as well, equals 1. And now let's figure out our A and B. Now, if we graph this, I like to graph it out. Oh, no. Hang on one second. And we're back. Sorry about that. In the center, what we have is 3, 2, and then we have A equaling 3C. We also have a focus, which is at 1, 2, and 5, 2. So I'm going to graph that, just because I can visually see. But you probably can do this without graphing, but I enjoy graphing it because 1, 2, 3, 4, 5, and 2, because it's just more plain to see where the major axis is going to be. Because once again, the major axis is located on where the foci are going to be along with the vertices. And what we can see right here is the foci on a horizontal axis at both of these spots. And you can also verify that right in the middle, all right, where our center is. Here's our center, focus 1, focus 2, all right, is at 3, 2, like it stated before. Now, from this, since it is another horizontal, we know that's going to be A squared is going to be under the x, and B squared is going to be under the y. Now, from here, we're going to identify the next values. We need to find A and B. So we are given some other additional information. It says that A equals 3 times C. Okay. So that really doesn't help us out because we don't know what C is. But we can find C because C is the distance from the center to one of the foci. So from the center to the one focus is going to equal, and you can see this right here, 1, 2 equals 2. The same length is going to be the same over here, which is 1, 2, and the C equals 2 as well. All right, so we can find this A equals 3 times C, and since C is 2, we plug that in there, and we find out A equals 6. So we take this value, or these values, and we plug them into our equation. So we have x minus 3 squared equals 6 squared plus y minus 2 squared, and then we have b squared equals 1. Well, now the next thing is we need to figure out what our b value is. Now the b value, we don't see because we don't know the minor, the distance from the center to the minor axes, or the plane of the minor axis. So in order to figure this out, we're going to use our other equation, which we've been using before, which is c squared equals a squared minus b squared. So we're going to take these values that we know, where we have c is 2 to be 2 squared, equals a, which is 6 to be 6 squared, minus b squared. Once again, we'll bring b squared to the other side. We have, this is going to be 36 minus 4 then, and we have b squared equaling 32. So we can find out our b squared equals 32, and we can fill this remaining portion out. 36 plus y minus 2 squared equals 32, and that's the equation of this particular ellipse with the given information. So that's another equation, or another way of how to find a standard form of equation of an ellipse. Given the center, given some other instructions right here, all right, and given the foci in this equation. Once again, find the center first, find the major axis, identify A and B, and use the information accordingly to help us solve it. All right, we have one more example we're going to do on the final tutorial, example number 4 of finding equations of ellipses.